All right, so let's talk about Mongo. So MongoDB is a database that it's one of several new databases that under the umbrella of NoSQL databases, meaning that it's not a relational database. Relational databases have been around for quite a while. They've been very successful, but certainly there are alternatives of how to store data, retrieve data, and certainly Mongo is one of many new databases that are becoming very successful as an alternative to SQL, right, to relational databases. So relational databases, they store data based on tables. That's their main way of splitting up the data across multiple buckets, right? That then you need to be able to reconstruct the data. You need to have references from many records on one bucket that reference other data points in another bucket, right? And the reason we break it up into multiple buckets or tables is the act of breaking it up. We call it normalization, right? And the reason we do that is because we want to minimize redundancy and inconsistency, right? That we want to be able to store the data only once. It can be retrieved only one way, right? So that no two different ways of retrieving would give you inconsistent results, right? That's the main reason why we break it up into multiple tables. So in non-relational databases, we don't have tables. Right? We don't have these references. We don't have these relationships. Instead, what Mongo is a database that stores data in objects. So you could think about it as an object database, right? You have an object instance, right? And then you write it into this database. And then later on, you just want to be able to retrieve it. Okay? So we don't say records in Mongo. Instead, we say that these are documents or that represent some object that is stored in the database, right? And typically in Mongo, we store these objects are formatted in JSON format. Okay, so all the JSON that we've been working all along, that we've been consuming from web services and we've been iterating over on Angular or React. Well, imagine those objects, storing them literally in a database and then retrieving them as is, raw JSON. Imagine being able to store raw JSON and then be able to retrieve raw JSON. Okay, the current implementation that we have has several transformation points, right? On the client, we represent everything in JSON. Then when we pass it over to Java, then it needs to be reconverted and re-represented in Java classes, yes? So there is a conversion between those two worlds, right? The JSON world and the Java world, yes? So there's a transformation that goes between those two layers, correct? And then there's another transformation that occurs between the Java world that it has it in object-oriented representation, and then the flat, SQL relational representation, correct? That's another transformation point, and we use JPA for that, right? JPA, we give it a Java class, and it magically maps them to some SQL table, correct? And it magically maps the properties of a Java class. It magically maps them to a table fields, correct? And even magically makes lists and references in Java classes, right? Where you have arrays or lists, it converts them into primary keys and foreign keys in the relational database, correct? So we have these two different conversion points or transformation points from the client side JSON, right, pseudo object-oriented kind of representation, to a full-blown object representation in Java, and then from Java back to a flat representation in SQL. And then back and forth, right? All this transformation is happening. Correct? Well, what if we could remove those transformations and say, well, I don't want to have to transform anything. I'm going to store the data the way I want to consume it without having to do any of this transformation. If it's already in JSON format, the way I want to consume it in React or Angular, why can't I just store it in JSON right in a database? And later on, just retrieve the JSON without any conversion. That makes sense? Right? And because JSON has become more and more prevalent as more and more applications are moving towards, they're moving to the web. And since JavaScript is the dominant language on the client side, and it wants to consume the data in JSON, there has been a lot of push towards representing data in the format that already we want to consume it in. Make sense? Why am I going to store it in a relational database if I'm going to consume it in JSON? Why don't I just store it in JSON? Right. So that's exactly what Mongo tries to fill. That's the gap, the need that MongoDB and many other databases are going towards. Right. So, all right. So Mongo, we'll use MongoDB. There is a free version of MongoDB, which I believe you already installed at the beginning of the semester. You should already have that installed and configured. We haven't used it so far, but let's start using it. Let's play around with it. We're only going to cover the absolute minimum today, right? As we progress through the semester, we'll dive into more advanced issues and topics and whatnot. If you've seen this in the 5200 or 3200, I'm sorry, I'm going to bore you to death. All right, so let's talk about MongoDB. All right, so it's already been installed. You start off the database using MongoD, right? That's the daemon that starts off the server, and I believe mine is already running. Yeah, it's already running, and typically it listens. The server, when you start up the server, it listens at this port 27,017. That's the default server name, server port. Also, the data that is being stored in the database is stored in a default location /data/db. That's where it's by default. It stores all its data, and you can configure all this so that if you want to go to run in a different port, a different directory, you can choose that. All right, so the Mongo database is already running. So instead, what we're going to do is I'm going to run the client for MongoDB. Just like in MySQL, there is a MySQL client that connects to a database, and you have a command line interface to talk to a database. Well, Mongo has something similar, right? You can start off a client that talks to the Mongo database. So Mongo. You type Mongo, it fails. Wait, what? So it's not running. I thought it was running. Okay. On Mac, you might need to do a sudo, right, to run MongoD. Right. On PCs, I don't believe you need to. So I'll do MongoD. Maybe. No, you shouldn't. No, it's just an executable, right? A folder that expands. That's all. You might need it to move it to /user/local maybe. So it depends where you put it. Yeah. But you can put it anywhere as long as you then put it in. You put the bin directory of Mongo. You put it in your path so that you can run MongoD and Mongo from anywhere. All right. So let's see. All right, so it's starting. I guess it wasn't running. There it is. So it's up and running. The server is running now. And in a separate tab, I'll run the Mongo client. All right, so it connected. It connected to the database. You can list the databases, show DBs. Right now, these are the databases I have here locally. Let's create. We can create a database, a schema for this particular class. Let's create one. All right. Let's see. You can You can create one just by saying use and then the name of the schema you want to create. So we'll create webdev summer 2 2018. Okay. All right, it created it. Once it creates it, you can ask for if there are any tables. We don't call them tables. Instead, we call them collections. Right? Collections. We're going to store lots and lots of JSON objects in here, and we put them in collections of objects. Right? And so there could be a collection for the users, a collection for the courses, a collection for the lecture, for the lessons, and whatnot. Yes? You can have all these types of objects. So let's start off with something simple. Let's create a collection to store all our users, right? All our students, for instance. Yes, let's create all our students. So to do that, let's see if we have any collections so far. Let's we can say show collections. And in the current database, we don't have any collections so far because we haven't added anything, right? We haven't added any users, no courses. There's nothing. Right, so our database is so show collections is similar to saying show tables, yes, but there are no tables, there are no collections. All right, so let's insert something. To insert something, all commands to modify, update, create, remove, manipulate any collection, all those commands, they all start with the DB. Right, they all start with DB, right? Followed by the name of the collection, db dot, and the name of the collection you want to manipulate. All right? In this case, we want to manipulate a collection called user. Right? So we're going to store users in here, so students presumably. Okay, so let's db student say, student. Well, let's say user, and then we'll use a role to distinguish what if they're a student, a faculty, a admin, or whatever. All right, so we're manipulating a collection called user that doesn't exist. So let's create it. We can create a collection just by inserting into the collection. All right, so let's insert something. If we want to insert, it'll be just the insert function. The insert function. All right, notice that it's following a very object-oriented dot notation syntax. Okay. That's just the syntax of interacting with the database. All right, so this will insert a record. Sorry, they're not called records. They're called documents. We insert documents, and the documents is just basically a JSON object that we're going to insert. Right, so we'll see lots of curly brackets in here. All right, so there's a curly bracket. We want to insert, and let's add a user. Here, this is just plain old JSON object. Well, they'll have name-value pairs, right? Comma-separated name-value pairs. So let's add Alice, comma password, also Alice, plus maybe a first name, Alice, and last name, Wonderland. Okay? All right, excellent. So let's insert it. And notice that it comes back saying, yep, one record was inserted. Right? Very easy. Everybody okay? All right. All right, so once it's there, if we go back and say show the collections, notice that now it does say that we do have a collection called user. Everybody okay? All right, let's add a couple more. Let's add now, let's add Bob, and Bob Hope. Okay, so we've inserted two records, two documents into the user collection. All right. All right. So we know how to put data inside of the collection. Let's see if we can retrieve the data. All right. To retrieve the data, we use a DB user. So remember, they all start with DB, followed by the name of the collection that you want to manipulate, right? Followed by what the operation on that collection. Right? In this case, we want to retrieve things from the collection. Okay, and in SQL, it would be something like select star from whatever, blah, blah, blah. Here, the command to retrieve data from the data is find. Not select, but find. Right? And it's a function. Now, the find takes as our arguments. The arguments that you give to find allow you to configure what is it that you want to find. Well, we already know the table or the collection that we want to retrieve it from. We know it's from user. Yes? This would be something like select something something from user. So we know the table. Yes? Right? What else do we give a select statement? Usually we give it the fields that we want. Yes? If we want all the fields, we might say star. We might also say where, right? Some predicates afterwards. Okay. If you don't provide a where clause, you retrieve all the records. Yes. And if you want all the fields, you just say star. So basically, you're not configuring anything. You want everything. So that's the equivalent at not providing any arguments to this find function. No arguments, meaning I'm not providing any names of the fields that I want, meaning I want all of them, and I'm not providing any predicates, right? Meaning I want all of them. Yes, all the records. So we do that. Notice that indeed we retrieve both of the documents that we inserted. Everybody good? Okay. Oftentimes these objects are huge, right? And they're very hard to read here on the console, right? So oftentimes what we could do is after that find, we can add some transformation functions that feed or stream through a transformation function. Maybe we want to sort it. Okay. Maybe we want to capitalize it. Maybe we want to do some transformation. Maybe we want to do a limit. No, we only want the first 10. We don't want the 1,000 users. We only want the first 10. Maybe we want to do pagination. So we can feed through several transformations through here. One of the nice transformation is that we can pretty it up. We can format it in such a way that it's prettier to look at, right? For our frontal lobe here, our vision. So if we pretty it up, notice that it adds a whole bunch of white spaces and tabs for us to be able to parse this a little easier. Everybody good? All right, it's just a little transformation, make it easier to read. All right, excellent. Let's insert another one. Let's insert another one. So let's change Bob. We'll say Charlie. And as first name, we'll use Charlie. And as last name, Brown. Okay? And we insert it. Is there anything wrong with my insert? Yes. Name? What do you mean? Oh, first name, last name. Yes, you see that, right? Notice that I forgot to put capital N name, right? And here as well, last name. So in SQL, this might be considered to be blasphemous, that we're inserting objects that might have a different schema. Usually in SQL, we first declare a schema and say that all records should follow this structure. Yes? Right? And they have to be spelled this way, and it has to be of this data type, and it has to be, you have to be very, very specific on what is that what you want, what you need. Okay? And perhaps here I'm even making it worse. I'm adding new fields. Okay? And a student. Right? So let's insert that. Notice that it did not complain, right? So this is one of the strongest differences between non-SQL and SQL, MySQL or relational databases is that we don't have the concept of a schema, right? There is no schema in relational databases. These are just objects that or basically what we're doing is that we're moving the responsibility of checking for the schema. It will not be the responsibility of the relational database anymore, right? We're shifting that responsibility over to the application level. All right, it will be the applications levels to make sure that these attributes, right, that the correct data types are the correct ones, right? That we're not inadvertently misspelling something, right, or introducing something of the wrong data type. All right, so it will not be the responsibility of the database to handle this. Although you can put some triggers and validations and whatnot, right? But by default, there is no validation whatsoever. Okay. What Mongo is good at is being able to very, very quickly store this data and very, very quickly retrieve it. Right. That's what its strength is. Right. Not doing validation or anything like that. Instead, that will be at the application level. Okay. Yes.
When you say application level, do you mean
Your app. Right. Your code. Wait. So typically, when you do validation, typically you want to do it as early as possible and as frequent as possible. So as early meaning even on the client, right? Making sure that you send them the correct JSON, that everything is following a particular model, right? That you're not generating these on the fly, as strings, but there's an actual model that you instantiate, right? And then you have your setters and getters and whatnot, right? And then you would pass it to the server. You do a validation again, making sure that again this instantiates a model on the server side. You validate and whatnot, and then you send it to a database, and perhaps you validate it again on the database, right? So as early as possible and as frequent as possible. Okay. All right. So if we do a find again, we'll notice that we do have our three objects. All right. The first two look like it's following a schema of username, password, first name, and last name. But this third one looks like it broke the Charlie Brown broke the mold. And notice that stat has just first, last, and roll. Okay, and that's perfectly fine. Right? Mongo won't bark at you, right? If you do that, it's instead the responsibility will be in our code, our server side code. We'll handle this. We'll fix this. Okay. All right. Excellent. Other things that you can do from the find is that you can provide arguments. You can provide here arguments that you can specify that I don't want all the records. I don't want all the documents. I want specific ones. Certain documents that meet a particular criteria. Maybe I only want the user whose username is Alice, right? Or I only want the users whose role is student, right? So I like to be able to filter that out. Okay. All right. So we can do that. We can provide an argument here to the find method that is a JSON object that it's going to be used as a filter, right? As a predicate. Okay, that you can say, well, I want the user whose role is student, right? And notice that it only returns Charlie, right? Or I can say that I want the one who has the username. User name, if we could spell, Alice, it returns just Alice. Make sense? All right. If you have multiple matches that you need, or multiple predicates, or multiple things that you want to match, maybe you want somebody whose username is Alice and whose age is or earnings or salary is whatever, right? You can provide them here as part of the whole JSON object, and it'll try to match all of them. Right? So if I can say Anne whose password is also Alice, right? It still returns Alice, but I can keep going. I can keep adding. So whose role is faculty. Notice that it returns an empty because there is no Alice, right? Whose role is a faculty. Make sense? Right. So it returns empty. All right. There are more sophisticated ways of doing more complex Boolean expressions, right? Where you can have ands and ors and nots and whatnot. Okay. So we'll do that a little later, right? So we'll just keep it simple for now, right? We'll do that maybe some more some more database stuff, maybe next week. All right. What else? What else should we be able to do here? Probably we like to be able to do as well is be able to update things, right? We like to be able to update records that already exist. Okay. And we can update, and update takes at least two arguments, right? The first argument is specifying which record, which document do you want to update, which one, right? And the second argument is what is it that you want to update? Once I have found the record that you want me to update, what is it that you want to do to it? Okay, what do you want? How do you want to update? So, for instance, I might want to update Charlie, right? I can say update Charlie. I would say username Charlie, right? Update Charlie. So meaning that is going to say I am going to update the record whose username is Charlie. Right? So this behaves the same exact way that the first argument to the finder method does, right? It's identifying the record, right? The second argument is what is it that we want to do to that record, right? So maybe we want to promote Charlie and change them to a faculty. The role now is Charlie is no longer a student. Now Charlie is a faculty. So faculty. Okay, everybody okay? Right. This is not going to work exactly exactly how we expect. Right. So let's do that. Notice that it said match one. I did find one record, and one of them was modified. I did modify them. Right. So one of them was modified. Let's see what happened. Let's do a find. Find all of them. Okay. Notice what happened to Charlie. Right, Charlie now only has the role. See that? All right. Basically, what happened is that we replaced the entire content of the record that was already there. We replaced it with this new JSON object. Okay. This is a little unintuitive. We would have expected that perhaps it was smart enough and say, well, I only want to change the role. Right. Well, to do that, actually, the syntax is slightly different. Right. So be careful. Right. The intuitive understanding is the wrong one, right? The intuitive one is that you think, well, it's only going to change that one field, and in fact, it's just we're going to replace the entire object with what we gave it. So Charlie's gone, right? We only have somebody whose role is a faculty. Instead, let's see how we would do this instead. So Alice, here's Alice. Let's try this with Alice instead, right? Let's update Alice. Okay, so instead of providing what we want to do, right, so for instance, say I want to change Alice's first name. Instead of Alice, I want to change it maybe to Alicia. Okay, if I do that, it's going to blow away the content of Alice, yes, and I'm only going to be left with the first name. We already saw that. Right, so that's not exactly what we want. That's not exactly what we want. Instead, what we're going to do is that we're going to wrap this inside of another JSON object that's going to specify a command to modify an individual field. Okay? Right? And that command is set. $set. $set, as you would suggest, as you think, right? It sets a specific a field, and the argument to that command, right? All commands, all MongoDB commands start with $. There's tons of commands. There's $and, there's $not, the $or, there's $in, there's regular expressions. There's a whole library, and we'll cover some of them. All right, there's just a very, very extensive, and we won't have time to cover them. If you want to, an extensive play around with that, the database course goes into much more detail. So anyway, so we want to change it. We want to say set, and we're going to close the curly brackets here. So set takes as argument the name of the field we want to set and the new value of that field. Okay, so let's do an enter. And it says, yes, I found one and I modified one. Let's do a find. And notice that indeed it worked. Notice that now we have Alice's first name has been modified, but we still have all the other properties in there. Everybody good? All right, awesome. What else? Well, we can also remove things. Yes. Yeah, you would have to instantiate this object. It's very inconvenient. So instead, I'm going to wait to do it in Mongoose. Yeah, it's very inconvenient to do it here. Yeah, yeah. This is not a string. The ID. That's another thing. Thank you for pointing that out. Notice that we're not adding any primary keys here to uniquely identify any of these records. Yes, but MongoDB is for free, right? Is creating these additional fields that we didn't generate them, we didn't provide these, right? Instead is automatically creating these new fields that they all start with _ID. You see that? Right? So notice the underscore. That means that's a field that is managed by the database, right? And you shouldn't be mucking around with it, right? It's a field that is handled by the database, right? That's the underscore. And then the name is ID. You can use it for queries and retrievals and things like that, but it's calculated and generated by the database. Okay? It's used to uniquely identify records. All right, so let me remove something. For instance, let's remove this bogus Charlie Brown record that was left over from there. We can remove by saying db.user.remove, and remove. If I do a remove, just like that, in SQL you might have expected that it would remove all the records. Okay, by default this is an error. It doesn't mean anything. You have to provide an argument. That will remove all the records. All right, the curly bracket. Okay, that curly bracket behaves the same way the finder. The first parameter to the finder behaves, right? To filter, to identify which records you want to remove. Okay? If you don't say anything, then that means you want to remove all of them. Right? So this pattern matches all the records. Pattern matches all the records. That's not what we want. Right? Instead, maybe we want to remove the record whose role is faculty. Okay? We want to remove that Charlie Brown. We say, go ahead, and notice that indeed we have removed one record. If we do a find, notice that they're all gone. Right? Charlie's gone. We only are left over with Alice and Bob. Everybody okay? All right. One more thing. The updates, we can also add new fields on the fly. For instance, Alice. Let's promote Alice to be a faculty. Okay, let's promote her to be a faculty. There we go. Notice that we get faculty. And if we do a find, notice that we have this new field in there that wasn't there before. Right? Let's do the same thing with Bob. And Bob, let's make Bob a student. Okay, and we do a pretty. Notice that we have one faculty and one student. Everybody good? All right. All right. That's all we're going to cover for Mongo. This is plenty for what we need so far. We'll come back to this next week when we do much more in-depth Mongo, and we'll play some more.